Hi, everyone. I'm Elizabeth Banta from the IBM Quantum Communications team. Thanks for joining us today. We're looking forward to an exciting discussion with key executives from IBM, JSR, and Cambridge Quantum to discuss solving business problems with quantum computing with a closer look at optimization. But before we get started, I just wanted to take a minute to thank everyone for joining us today and to run through a few quick items. So first, this is our last virtual panel for the summer focused on quantum, and we're really excited to be able to convene this conversation focused on key topics that we're really passionate about, including software development, skills, and now how we're helping our clients to solve real problems with quantum computers. Second, there's a few links that I want to highlight in the top left corner of your screen. So this morning, we announced that IBM has reached quantum volume 64, which is a widely accepted metric of progress as the industry marches toward quantum advantage. And we've also included links to our recent IBM Japan quantum announcement and a blog from earlier this summer from Jay Gambetta talking about how we're making optimization easier for clients. And throughout the event, you'll have the ability to submit questions in the Q&A box, and we'll address those at the end of the call. So within the next day or two, you'll also be able to view this replay at this same link, and we'll be able to share that with you after this is finished. So if you have any other questions, feel free to reach out to your IBM representative, and we can definitely get those answered. But with that, I want to turn it over to today's moderator, Peter Rutten from IDC, where he's a research director within IDC's enterprise infrastructure practice covering research on quantum computing platforms. Peter, over to you.
Thank you, Elizabeth. Welcome, everyone. We have a great conversation ahead of us with what I think are some of the brightest minds in the quantum computing industry today. And they will introduce themselves shortly. I've been given 3 minutes to start today's discussion, and of course, I'm going to use them by sharing some IDC data that you might find useful. These are from an international study on the quantum computing industry that IDC recently completed. So here we go. 72% of businesses say that they are very interested in quantum computing. 52% are planning to experiment in the next 18 months. 22% are actually testing, evaluating, experimenting with a quantum service today, and 11% are already in the process of operationalizing a quantum use case. The top 3 industries that are implementing quantum computing are chemical and petroleum, distribution and logistics, and financial services. But there are others, healthcare and life sciences, and manufacturing, for instance. Let's talk about some use cases. For chemical and petroleum, some top use cases are product design, drilling locations, oil shipping, refining processes, seismic imaging, and finding surfactants and catalysts. For distribution and logistics, the big use cases are freight forecasting, network optimization, resource distribution, and vehicle routing. And for financial services, use cases are credit scoring, derivative pricing, finance offer recommendations, fraud detection, investment risk analysis, portfolio management, and transaction settlement. What are these businesses expecting from quantum computing? The top expectations are improved AI capabilities, improved security, improved R&D, better ability to simulate physical processes, and the ability to optimize security, optimize current processes using quantum computing. In the next 24 months, 28% of businesses expect to increase their quantum computing use by 10%, and 39% expect to increase it by 10 to 20%. So that's quite significant. You can see that quantum computing has rapidly advanced and emerged as a reality in the past few years. Vendors have seen breakthroughs with quantum computing and the release of more powerful quantum processors. There are many quantum startup companies today, and they are also finding success in their own discoveries and partnerships with large vendors. Although quantum computing is rapidly advancing, quantum advantage over today's classical computing has not yet been achieved due to technological challenges like environmental noise and decoherence of qubit states. Today, the focus of many commercial research groups is in fields that will see the benefits of quantum computing. The automotive industry, for example, is emerging as a strong quantum computing market through quantum-based optimization. By the way, in today's discussion, whenever we talk about quantum-based optimization, we're referring to optimization technologies that are executed on a superconducting quantum computer. With that, let's ask the panelists to introduce themselves. Jamie, do you want to start?
Yes, thank you, Peter, for that introduction. I'm Jamie Thomas, and I'm General Manager of Strategy and Development from IBM Systems. Pleased to be here with you, Peter, Denise, and Yuya to talk about this important topic today.
All right, who wants to go next? Denise?
Sure. Hi, everyone. My name is Denise Ruffner. I'm with Cambridge Quantum Computing. Cambridge Quantum Computing is a UK-based startup, 6 years old. It has about 100 employees, of which 70 are scientists. I came to Cambridge Quantum a year ago after working with the IBM Quantum team. I also lead the Women in Quantum and the One Quantum organizations. And at Cambridge Quantum, I lead a business development group where I'm responsible for customer engagements as well as corporate strategy.
Thanks, Yuya.
My turn?
Yes.
Yuya, do you want to introduce yourself?
Do you hear me?
Can you hear me? Yes, we can hear you, Yuya. Go ahead and introduce yourself.
Okay. Yeah. I'm sorry. The connection seems very bad. I think my voice is reaching, but your voice is very hard to listen to. So
Okay.
it's not meet your expectation. So now it's a self-introduction, right?
Yes. If you
Okay.
wouldn't mind introducing yourself.
I am Yuya Ohnishi, and this JSR chemical company in 2017. Before that, I was an assistant professor in academia. I was doing some high-performance computing in quantum chemistry field. Now, I am Deputy General Manager of Materials Informatics Initiative. So I'm doing very usual materials informatics, and also I'm in charge of the quantum computing. I'm a residence in KO Q Hub, which is the IBM Q Network Hub at KO University. So I've been doing quantum computation for 2 or 3 years. So it's very kind of amateur in this field, but I've been learning so much and very exciting about that quantum computing field. Thank you.
Great. Thank you, Yuya, and it's great to have you on the team. So Jamie, IBM has been investing quite a bit in quantum to help customers solve business problems in different ways. Can you talk a little bit about IBM's efforts and why quantum is so relevant for solving some of these problems, especially those that are considered too complex for classical computing, the type of the computing that we have today?
Sure, be glad to. First of all, IBM's dedication to quantum has spanned decades of innovation to allow us to get to this point. We firmly have believed for a long time that quantum, with its unique properties, the ability to combine quantum mechanics with information technology science, would allow us to do things that classical computers cannot do today. You mentioned many of those examples in your introduction, Peter, that I thought was excellent. But one primary example is this whole area of molecular modeling, which I know Yuya will be an expert on. because molecular modeling affects so many industries, from chemistry, material science, to pharmacology, to advanced manufacturing principles. To that end, we felt that we needed to invest in technology, hardware, and software to advance the goals of quantum. And so today we're really pleased to be able to announce an advancement in our own fleet of machines in the cloud, the achievement of quantum volume 64, which is a major milestone for our efforts at IBM. And what this really means is quantum volume is a measure of the power of the computer to actually solve some of these problems. It really takes into account a number of dimensions of the machine, including the number of qubits, coherence, and effective error correction. Our advancement here was really achieved by a full stack approach, the ability to tune all elements of this system, from the software to the hardware, the superconducting processor, as well as the electronics that support it. So we're really excited to be here to talk with you and the team here about this advancement in quantum.
Thanks, Jamie. And that's an exciting announcement. I think quantum volume is increasingly being accepted as a sort of a metric for the progress we're making with quantum. Denise, Cambridge Quantum is focused on helping customers getting started with quantum computing. So you're really out there in the field trying to understand what businesses are trying to do. Why are you investing in quantum?
The reason why we're investing in quantum is because we have a vision, a very strong vision, that quantum computing will revolutionize computation. And it will do that by making certain types of classically intractable problems or NP problems solvable. And so we're excited that IBM and other, we have IBM as a partner and as an investor. And we feel that the development of quantum and the development of these NISQ devices is a huge opportunity for us. We write software, and we have strong development roadmaps around these NISQ computers. And we do see the potential for quantum supremacy, or the ability for a quantum computer to outperform a classical computer, coming up within the next couple of years. We're very excited about the progress that the manufacturers are making. At Cambridge Quantum, we have a powerhouse team of scientists. We have an amazing group of Fortune 500 customers, and a very disciplined methodology that we use to help our clients get started to innovate in quantum computing.
Excellent, thank you. Yulia, you're basically representing the end client's point of view today, working with quantum for actual business purposes. There are all kinds of business problems that you can potentially tackle with quantum. In your experience, what types of problems are a good place to get started?
We started with quantum chemistry, and I think I need to add some point in for JSR. So JSR is specialty chemicals company. Is very treating photosensitive materials, so such as display materials, and also the near infrared light cutting filter, and so on. So in such materials, we need design a materials based on the very great quantum chemistry calculation. We have been using the traditional quantum chemistry methods, but the accuracy was not very sufficient. So our target is accurate quantum chemistry calculation of such photosensitive materials. So quantum mechanical simulation is one of the expected to be one of the applications which does not require the NISQ for the NISQ error. So we started the quantum chemistry calculation.
Okay. Excellent. Jamie, do you want to talk a little bit about what you're seeing clients doing across various industries, getting started with optimizations?
Sure. And just to reiterate what you said a little bit there, seriously, even in our business in IBM, the creation of new materials for some of the applications that we use within our product lines, like the IBM mainframe, are very difficult. And there's only a few organizations in the world that can meet our needs. And so being able to expand upon that with applications of quantum, I think will really help IBM and many organizations that are in industrial applications like ours. But along the lines of optimization, we have released quantum optimization algorithms. And the reason why we've done that in the past few months is really to allow an easy on-ramp of those developers who are classically trained in optimization around things like CPLEX to be able to take advantage of the quantum computer without being quantum experts. And we do see a broad application of optimization across many industries. So when you think of optimization, clearly one that's near and dear in my heart, given what I do in IBM, is supply chain management, right? This whole area of complex logistics that are involved in every supply chain around the world. Certainly, we see optimization used within the financial industry. You touched upon that in terms of options pricing, the ability to do settlement trades more effectively, and risk management. So the notion that we can provide a more frictionless on-ramp for these classically trained developers is really a goal of our optimization algorithms that we provided. And we're seeing participation. We're already seeing organizations like JP Morgan Chase contribute to our optimization algorithm efforts. So really, really excited about the future here.
What are you, Denise, what are you seeing in terms of optimization challenges that your customers are trying to solve?
So again, the goal of quantum optimization is to develop quantum algorithms that solve these NP-complete problems where no efficient solution has been found. So it's truly an exploratory area. And Cambridge Quantum has their own approach using a ZX calculus expertise where we can optimize circuits and reduce circuit size. And we find that this approach is getting us a lot of traction. In April of this year, we announced a collaboration with Nippon Steel in Japan around optimization. And we do have other projects with large companies. So a couple of the areas where we're working on optimization is supply chain for life science companies. This has been particularly relevant during the time of COVID, as well as we're looking at efficient transportation routes for shipping companies. In other words, a solution for the traveling salesman problem, which I think everybody in the audience knows how hard it is to figure out the optimal route to deliver 50 packages or go to 50 places in a day. We're also looking at process optimization in chemical reaction networks to increase yields. So there's a lot of areas in chemistry and logistics where optimization applies. And these NISQ quantum computers, we believe, will greatly be able to help us and be able to solve these problems that have been previously unsolvable.
Thank you. Yuya, can you talk about how this can be applied to materials as you were earlier talking about?
Yes, for the optimization issues, I think we are also interested in this field because this could be combined with materials informatics techniques, machine learning, and quantum chemistry calculation and optimization. So now, we can generate a bunch of data by using computational method. So when we design a new product, we need to find a good combination. For example, we are making some composite of polymer. There are so many monomers, and we have to choose a good combination of that with the good polymers to find the best combination, I am hoping that the quantum computer helps us. So in fact, this week, I think yesterday or so, a paper is reported by IBM Zurich, potentially enables us screening molecules having desired properties. Yeah, that's a very fascinating field. Thank you.
Thanks, Yuya. Let's talk a little bit about some other areas where optimization, quantum-based optimization, could be applied. Jamie, you briefly mentioned supply chain. Can you talk about that a little bit more?
Absolutely. So I've had an exciting time as the owner of IBM supply chain and manufacturing during this pandemic period. I guess it's tested our resilience in ways we never anticipated. When we think about a supply chain for complex products like ours, it really starts at the identification, discovery, and creation of the materials, as we were discussing there with Yuya, all the way into making sure that those materials and all the downstream artifacts of our supply chain are available. As you can imagine, the combinatorial issues that we had to deal with during something like a pandemic, with various countries shutting down and opening up, and understanding where we could get supply, how we could get the supply routed, given the complexities of air travel, as air travel was dramatically affected. And a lot of our freight, all of our freight comes air for the most part. So the number of flights being reduced over the pandemic period definitely affected our routes that were available, as well as the rates, of course. All of this is just another example of why it's so important to think about supply chain logistics intently and understand how we can apply new techniques like quantum computing to solving these kind of problems. Because when you get into a situation like this, it's not only the complexity you have to deal with, but the time element. You only have so much time to solve these kind of challenges, to be able to get your components, if you will, to your factory, to be able to produce the kind of critical products that need to be made available to clients, like our clients, right? Given that we are running a lot of the financial concerns, the healthcare concerns around the world, these products were absolutely critical to get to those clients. So a little bit about supply chain. I think there's a lot more we can do with supply chain and quantum as we move forward.
Great. Thank you, Jamie. What do you expect in terms of quantum-based optimizations? What kind of advantages do you and your business expect from that?
Yeah, in addition to Jamie's point, I hope optimization shorten the time to deliver in materials design. Beside the materials design, I think the optimization by quantum computer eventually reduce the production cost in manufacturing, the cost in plant. So several algorithms are proposed for fluid dynamics simulation, which is frequently used to design condition of mass production of chemicals. So we have not started that kind of project related to the plant operation optimization yet, but we are very excited about this application also. Yeah.
Great. Thank you. Denise, do you want to add anything, the advantages you expect from quantum-based optimization?
So I think quantum-based optimization is really going to help us, I think, improve supply chain. Right now, I think all of us have been stressed by supply chain issues in our everyday lives. So kind of one of the first places that I do look at it is in supply chain. However, the optimization, or kind of that problem set, is a huge problem set that can be applied in many different disciplines, whether it's chemistry or finance, as Jamie mentioned. There's a lot of different applications for optimization. So I view it as one of the transformative solutions that quantum computing will bring the world.
Listening to all of you, quantum-based optimization seems to have distinct potential advantages, but businesses are really sort of in the beginning stages with that. Can each of you talk a little bit what future projects might look like? What kind of improvements also would be helpful to realize those projects? Denise, you want to start?
Sure. So Cambridge Quantum Computing is helping our customers develop quantum software that can be used by their staff without quantum expertise. So our goal is our development work is ultimately turns into a turnkey solution so that people who are not quantum scientists can take advantage of quantum technology and the quantum development work that their team has done. So it's development of software platforms that, to me, that is where our future is, that there will be software platforms that will kind of be seamless, that just run on a quantum computer, and will be able to solve problems that we previously haven't seen. So I see that as delivering improvements in supply chain and improvements in optimization-based problems that the algorithm has been designed for.
Right, Jamie?
Well, I certainly agree with Denise's point around algorithm focus to allow reach to a broader set of developers. I think that's absolutely critical. And that is one of the reasons why we've invested so heavily in our network, which is now over 115 members across commercial, academic, and startup enterprises, to really embody this notion of co-creation. And so we have many examples that have been published in over 250 papers of what the network has done with us. And if you go out there, there's certainly a lot in the materials area that we've spoken about. I think there could be more in logistics and quite a few in financial services. Financial services is really invested in seeing the benefits of a lot of the optimization out there in the written papers around things like the ability to price options more effectively, risk management. There's a really good paper on settlements and the complexity of settlements and how quantum can help with the settlement industry, which is a huge industry in financial services. And it affects all of us, right, when we're trying to trade in the stock market or make certain moves within financial entities. So I think it's this notion of co-creation and making sure we focus on the talent across the industry required to make this a reality.
Thanks. And Yuya, what kind of, you talked about what you're currently working on. What kind of future projects do you see for JSR related to quantum?
So, as I said, we are trying to doing quantum chemical calculations. For example, at IBM Q Network Hub at Keio University, the chemical member companies, Mitsubishi Chemical and JSR, and the Keio research, Keio University staff and IBMers have been doing the quantum chemical calculation of OLED, the organic light emitting diode. And that paper is recently uploaded to arXiv. The project is mainly led by a researcher from Mitsubishi Chemical, Dr. Gao. And the reason why we are doing such a collaboration, the reason why we could do such a collaboration is that molecule is very interesting and very important to achieve the energy efficient society. So, and also in JSR is also doing some quantum chemical simulation of for prototype molecule photoresist. I think that in most cases, the chemical companies are trying to design more energy efficient compounds by using the quantum computers, because such molecule is very difficult to calculate in the traditional quantum chemistry method and on classical computer. But we hope that that using the quantum computer enables us such very difficult calculation. And also, all the member company, including financial companies in KOQ Hub, are looking for the application in quantum machine learning, quantum AI. Yeah, I guess this is very experimental field, but it's a very educational topic. So we have to understand many probabilistic behavior of quantum computers. And the good point is the students in KO University are getting experience. And we hope that they are becoming the very talented, very trained researchers in the future.
Great. More talent in this industry is what we need, right? Like I mentioned in my introduction, businesses are really starting to invest in quantum. And my question to all of you is, why should businesses that are not there yet, that are not doing this yet, for whom this is not yet on their radar, why should they invest in quantum today? Jamie, do you want to start?
Well, I think we can all reflect back, go read history and understand what really happened with the advent of the classical computer. When they first came out, we didn't really think we could do much with these computers, and now we can't live without them, right? As we've discussed here, quantum is going to affect every industry, and it is really up to organizations like the ones on this call today to make sure that we have the right workforce of the future. So our investments in our network, our hubs that Yuya described, we have one in Tokyo at KO University where he participates, are really fundamentally important in that endeavor. We also announced and signed agreements with Japan and Germany to really focus within those countries how we create the workforce of the future. And of course, we've made access to our computers in the cloud free for anyone that wants to access them. We have over 250,000 registered users accessing those computers today. And we're fundamentally really focused on digital assets for education. So open source textbooks, YouTube series of our experts out there talking to those that want to learn more. And of course, we have initiated things like Quantum Summer School in this pandemic world, where we had an online summer school for those interested in learning more about quantum. So I think it's really up to us to follow the trail that we saw with classical computing over the last 60 years and make sure that we take advantage of quantum. We can certainly see that if we had quantum computers today, that they would make a difference in our fight against things like COVID-19 and the ability to get things done faster that could make a huge difference for the world.
Right, right. Yuya?
Yes.
So the question was...
Jamie.
I'm sorry? Yuya, so the question was, why should businesses that are not investing in quantum today, why do you think they should?
So, as Jamie said, at the end of July, a new consortium has launched in Japan. The name is Quantum Innovation Initiative Consortium, QIIC. The head is the University of Tokyo and the potential members. I mean, any members has not officially signed up, so please be careful when you write this point. So anyway, the potential members are KO University and 8 enterprises, who are Toyota, Hitachi, Toshiba, MUFG, Mitsubishi UFJ Financial Group, Mizuho Financial Group, Mitsubishi Chemical, DIC, and JSR. So from this consortium, we can access to the real device of IBM and collaborate with academia and IBM. I hope this encourages young people so much. So not only in academia, but also in such industry, huge demands exist. So one of the most important reasons why we need to invest in quantum now is the cultivate of talents in the future. That is my opinion.
Mm-hmm. That's great. That's a great lineup, Yuya. Denise?
Well, when we talk about investing today, I want to mention Cambridge Quantum Computing is also an IBM Q Hub. So wanted to mention that. But one of the things that I see, and it's consistent, every time I talk to someone about quantum computing, they say, oh yeah, it's 5 to 10 years away. Oh yeah, it's 5 to 10 years away. And this, I mean, Jamie knows this. We've been in quantum computing for a long time, and that message hasn't changed. So 5 years ago, it was 5 to 10 years away. And I think that's not true anymore. With the advancements, for example, the advancements that IBM announced this morning on their NISC computers, we can see that quantum computing is growing in its capabilities, and quantum supremacy, or the ability for a quantum computer to outperform a classical computer, is in the reach of scientists, and it's going to happen. We had an example last year, but there will be more examples, and those examples are not 5 to 10 years away. I'm guessing they're 2 to 3 years away. I look at the development roadmaps of these devices; they're very exciting. And so, what I want to say to everybody is the time to get started is now, before your competitors develop solutions that are going to be transformative for their businesses. So it's important that everybody embraces quantum computing, jumps in, and gets started. And as Jamie said, again, there's a lot of education, so that if we all need to learn more about it, as well as I think companies need to really start looking at what their point of view is on quantum, how they're going to adopt quantum, what their timeline is. But to write it off as saying it's 5 to 10 years away, I think is short-sighted. And I think people need to start planning now. Now is the time. The advancements are going to come faster and faster. And I think it's going to impact all of us. And I can say at Cambridge Quantum Computing, what surprised me is that how many customers call us every day and want to engage in quantum computing. And so I want to say that if you're not, you really need to think about it, because your competitors are calling us. So please think about it and start getting education and coming up with what your plan is going to be to add this technology to your armament in terms of how you're solving solutions for your company.
Great, thank you, Denise. So I can definitely second what you just said about competitors. We're seeing in our research that that is definitely a driver, that businesses are looking over their shoulders and thinking or seeing their competitors getting into quantum and developing the talent. And of course, developing the talent is very important. Yuya, you mentioned that. I think all of you have clearly spoken here to the fact that quantum is a reality, is already being used today, is a very important aspect of future thinking for most businesses. I think we've talked about some use cases like molecular modeling. Yuya, you talked about materials research. Jamie, you mentioned supply chain. We've talked about logistics, chemistry, machine learning. The quantum computing capacity exists to start taking advantage of these use cases with quantum computing. The platforms exist, the networks exist, and we're all, it sounds like, trying to train the talent to develop this further. So thank you. With that, I give it back to Elizabeth.
Great, thanks, Peter. We have a couple of questions for the panelists. First, Jamie, this one's for you. How does IBM's announcement to reach quantum volume 64 impact how clients can use IBM's quantum systems?
Well, once again, this is really a statement in the advancement of the capability of the computer, the power of the computer to actually solve problems, right? And that is one of our key inhibitors right now, is that the technology must advance at a rapid pace in the next 2 years to really get to a point where it exceeds the ability of what classical computers can do today. So this kind of technology milestone is critical along with some of the other things that we've stated here around building the skills and also having a worldwide reach, if you will, across the right industries. But without the technology, we're not going to be able to execute. So that's why this milestone is so critical.
Great, thank you. Yuya, the next one's for you.
Yes.
So I know you talked a little bit about your OLED research. Can you contextualize a little bit how this might be applied in the real world down the road?
Yes. As I briefly explained, our target molecule is very it's very related to the energy efficient materials. For example, in the past, the Mitsubishi Chemical researcher did some prototype calculation, lithium oxide calculation, which is the prototype, the air battery. And also we did a calculation that OLED, so which, because we need to design a molecule more efficiently, the light that emit the light more efficiently. We need to understand the nature of the molecule. For such purpose, the quantum computer is very suitable. Of course, eventually, people want to create the nitrogen fixation calculation. That is, I'm a quantum chemist, and that is a dream to design a good catalyst by using the quantum chemistry method. But we realized that traditional quantum chemistry is not sufficient to design to calculate such very complicated catalyst. So we hope, I think that many of quantum chemists want to design such such catalyst for nitrogen fixation. Is that answer? is it a good answer for you?
Yeah.
That's great, thank you. And then just a final question for Denise. Because Cambridge Quantum is based outside of the US, could you talk a little bit about what interest you're seeing from other clients and companies around the world?
Sure. I wanted to start off by saying we are based in the UK. People always say Cambridge, oh, Boston. No, the UK. But we do also have offices in the US and in Tokyo. So we consider ourselves a worldwide company. That said, the majority of our customers are out of Europe. We do have quite a few European customers, but we also have quite a following in Japan and in the US. So I feel like we've done a very good job of finding customers in kind of worldwide. So that's been really great. We do have teams on the ground in each of the countries, which also helps, or helped when we could travel and be face-to-face with people.
All right. Was that the last question, Elizabeth? I think that was the last question. Okay.
Yes, it was.
All right. Well, thank you, Jamie, Denise, Yuya. This was a really great conversation. I certainly enjoyed it and learned quite a bit too from everything that all of you are doing. It's a very exciting field. At IDC, we're certainly following it very closely and seeing a lot of progress being made. And judging from what you've been telling us here today, you too are making a lot of progress, at IBM, at Cambridge, and at JSR with quantum. So with that, I want to thank you all. Thank you for a great conversation.
Thank you, Peter.
Thank you, Peter.
Take care.
Bye.
Bye.